Hello everyone. This video explains six trigonometric ratio: sine, cosine, tangent, cosecant, secant, and cotangent. Say we have this right triangle and we know about the relationship between those side lengths using Pythagoras theorem, like a squared plus b squared that is equals to c squared. But how can we find a relationship between an angle, theta here, and those side lengths? This is when we use the trigonometry ratio to find those relationships. We will see trigonometry ratio that applies for a right triangle, starting from sine, cosine, and tangent of an angle. Trigonometry is a way to show the relationship between side lengths and angles inside a triangle. To do so, I drew the same right triangle with corresponding colors, but this time I'll write those sides in a different way. The opposite side of the angle, theta, is the red one, so I'll say opposite, abbreviated to OPP. And there are two adjacent sides for the angle theta, which are in green and yellow color, but we call the longest length as hypotenuse. So we always take the shorter one as the adjacent side. Because we only look at the right triangle, the angle between adjacent and opposite sides is always 90 degrees. Have you heard SOHCAHTOA before? This is the key word, or more like mnemonic, for trigonometry related questions, and explains the sine, cosine, tangent relationship between the angle and sides ratio. S is representing sine, O for opposite, H for hypotenuse, and C is cosine, and A for adjacent, and H again is hypotenuse. For TOA, T is tangent, O is opposite, and A is adjacent side. They are the abbreviation of those meaning. So means sine can be expressed as a ratio of opposite over hypotenuse. Ka means cosine is expressed by adjacent over hypotenuse. Similarly, TOA is tangent expression with ratio of opposite over adjacent. Using this ratio, we can find sine theta and cosine theta and tangent theta values with side lengths of A, B, and C for this above right triangle. So sine theta is opposite over hypotenuse. Opposite is B. Hypotenuse is C. So it would be B over C. And next, cosine is adjacent over hypotenuse, which is A over C. And last but not least, tangent theta is opposite over adjacent, which is B over adjacent is A. So B over A. Next, we will see cosecant theta, which you can write it like this, and secant theta, and cotangent theta. Cosecant theta is reciprocal of sine theta, which is basically changing the numerator value and denominator value of sine theta ratio, which is C over B. Similarly, secant theta is reciprocal of cosine theta, and again, after changing A and C from cosine theta ratio, we can get C over A. Cotangent, from the name, cotangent theta, from the name, you may guess is reciprocal of tangent theta and the inverse of B over A, which is A over B after changing those top and bottom values of the fraction. Angle theta and those ABC values were used in general expression, but they can be changed into numbers to specifically find the measurements of a right triangle. We'll see more detailed examples with values in following videos. Thank you very much for watching the video, and good luck on studying.